Good evening once again. You're welcome to another interesting class on AFS 220, Wildlife and Fisheries. We had earlier taken two classes, and I want to encourage you to go to your course page to view, all these things. There we have the general news and announcements. You can meet your facilitator here and the profile. Of course, the course outline is stated here in the resources, the library, visit the library, and the virtual library of the entire course. Then here we also have, online facilitation sessions that we have done in the past, the first week, the second week, and today I'll be doing the third week. So please go to your platform, and you can always go to your platform and just join the facilitation class. I'm expecting you to join. So in the first class, we look at the present status of fisheries in Nigeria, and there we're looking at the fishery activities and resources, the major constraints, while the demand for fish is yet to be satisfy the teeming population in Nigeria. However, we also told you that we have a lot of, continental shelf, 200 nautical miles, where we have the shellfish, the finfish, and the exotic species. Now, please go and watch all of those materials. They are all online for your consultation. And secondly, we looked at the morphology and the basic structure of fish. We're looking at the various, the biometric characteristics, the different groups and the characteristics of finfish, the shellfish, and the commercial fish. So the lesson note is there, the instructional video is also there. Then the last Zoom class also is also here. I would like you to participate in the discussion forum, both of 1 and 2. I will likely go ahead and open it up. I still want you to make contribution. Today we'll be looking at water quality management, and you know that it is your success in aquaculture, which is the main salvation, as it were, for fish production, because aquaculture is the fastest growing subsector in West Africa. It's quite growing so that it can meet the teeming needs. And the success of aquaculture is predicated and basically based on the aquaculture itself. So you may need, to pay attention to that. The lesson note is there, and also the Zoom meeting of today will be posted on this same platform. So always come to this platform. I also expect that we should also participate from tomorrow morning, from 8 o'clock, go to the discussion forum and just make your own contribution. The question is that, do you think that the interrelationship between water temperature and dissolved oxygen is critical for the optimal production of fish? Do you think so? So please just offer your own mind. You can comment on other or your colleagues' posts as well. So just feel free, explore everything that is on that platform. You will be glad you do. So today, I'll be taking you through this first lesson, okay? I'll be taking you through it, and I want you to please listen attentively, to all that will be said today. Okay, you're welcome to the class today. My name is Dr. Awolumate Samuel. We'll be looking at the water quality management in aquaculture. You can always reach me through this email. Like I told you, water quality is the most important factor, in fish health. And for optimal productivity, you need the health of the fish to be in place. At the end of this lesson, you will come to know, you'll be able to state the importance of good quality water, in aquaculture. And when you see good water quality, when you see water, you know whether it is good or it is not good. You'll be able to differentiate both of them. And you'll be able to explain the need for making the right choice, for if you want to have maximum production, what kind of choice of water do you need for your fish farm? Thirdly, you'll be able to illustrate how you will manage a case of phytoplankton, bloom in your fish farm. You will know, how do I manage it? You should be able to illustrate it. And if the situation arises in your fish farm like this, we'll define many of these terms later, you'll be able to handle the situation. Then finally, you'll be able to explain different ways of managing water sources to improve its quality. By way of introduction, you can see this entire water body in this the right side of the screen. We have different millions and millions of fishes of different species. Remember the last, we're looking at morphology and different species. We have millions of different species, in the water body. And of course, fish is equals to water. No water, no fish. So we should know all of that. Now, and it is this water body, inside this water body, that fishes perform their bodily function. They breathe, they feed, they grow, they excrete, their waste products. They maintain their salt balance in this water body. Remember that, in the last lesson, we're talking to you about the morphology of fish. But today, we are taking you further to look at the water body that, the fish lives in. So here also, they reproduce themselves also in multiple dimensions. So you need to understand also the physical and the chemical property of water, that it is very, very critical to the success of the aquaculture. Now, if you don't know all of this, as a basic introduction, if you don't know all of this thing, you cannot operate a successful aquaculture. Remember, we also told you about the artisanal fisheries and the aquaculture. Okay, but aquaculture is just, where you confine the fish away from the harvesting we find in the marine environment, the lagoon environment, and the rivers. But this aquaculture is a way of culturing your fish in an enclosed, regulated manner, in ponds, in concrete tanks, and the high-tech dimension recirculatory system. Okay, so you need to understand that this is where the fish function. All their characteristics is fulfilled in water. Now, we need to clearly know that, water has its own physical characteristics in different form. As you can see in my right hand, we have the solid, we have the liquid, and the gaseous state. Of course, if you apply heat, melt it, it becomes solid. If you keep boiling, it becomes gaseous. Of course, back to the solid state, you go through condensation and freezing. Now, you need to know that fish take on the temperature of their environment. Okay, when it is hot, they take on that environment, whether it is cold, whether it is salty, that environment, except it's not very conducive for them, they take on the environment, and they cannot tolerate rapid change in environment. They cannot tolerate where you just move from a particular temperature to the extreme. They can't survive it. But over time, when the temperature change over time, okay, they can gradually adapt to that temperature. So you need to also know that that is a major thing that you need to know about fish. So looking at the water itself, we say that unique density quality of water. What do we mean? The denser the water become, denser as they become cooler. Okay. However, increasing in volume allow water to flow rather than sink. That's a very important thing. So if the water become colder, the volume increases. Instead of it to sink, it floats. And of course, a characteristic, this particular characteristics that we mentioned above, prevent pond from freezing solid. Okay, it doesn't allow it. And of course, it's good for the fish, because once it moves to become solid, you know that the fish, that water body is no longer conducive for life again. Now, we will look also at the water balance in fish, because fish lives in different water body, the marine fish, the freshwater, but in between those two, we have the brackish water. And we told you in that last lesson, if you have listened to it, that any water body that has salt level greater than 35, it is salty water. Marine fishes survive in those ones. Whereas between 1 and 34, 134 is a brackish, but less than 1, it is the freshwater fishes. So we're saying that, you see, if you look at this picture here, we look at the water at this point. So fish drink water, and through osmotic laws, through their gill, it goes into the atmosphere. And of course, urine, it produces urine into the water body. This applies here as well. Osmotic gain happen here, whereas here is osmotic loss. Why? Because the fish, the fluid here, the body fluid here is hypoosmotic. That means, look at it here, fish drink large amount of seawater. Remember we said there's a large quantity of seawater, salt here, and excrete only small amount of highly concentrated salt. But the freshwater, the reverse is the case, meaning that they drink, they struggle to maintain their water, the salt level in their water, because they will of their own take small amounts and excrete large to maintain their water balance, their salt balance. So the freshwater fish is hyperosmotic water fluid, meaning that they look at these solutes. Salt from seawater enter into them, but they excrete it out. Only small amounts, because the water body itself is salty already. And urine also come out in small. However, this one will, the fish in the freshwater body will push away large quantity of salt water, because there is constant uptake, active uptake in their gill. And that's why if you want to transport fish from one place to the other, you need to add salt solution to it. Okay, that is very important if your fish is going to survive over a period of time to move from one pond to the other. Now, I just want to take it a little thoughts and think a bit. Do you think a good water quality is critical to aquaculture? Just think. Now, this activity, please, you can email me on your own response to this question. Just email me. Let's have a discussion on this subject matter. Okay. Now, we have different sources of water. Okay, we have the river, the stream, the reservoir, the rain, the pond, hand pump, and the well. And now of all of this, now we said the river, the well, and the stream, of course, the stream, which is like a spring, are the best sources of water, because you see, both of these one flow, and so it does not retain any particle, anything that has polluted the water. It constantly purifies itself over time. But the well also, it goes down, to the subsoil, as not to allow any pollution, of the first water, the water table that is often polluted, and that's why it is considered to be of high quality. So if you want to have maximum fish production that is healthy, you need to take into consideration your source of water. And we say river, streams, and well, as we find, it's been proven to be the best source of water. Of course, like we said, it's a limiting factor in commercial fish production. Really, like we said, no water, no fish. And you need to, invest in the right source of water. The farm I have, personally, what I did was to locate my farm beside a river that is far away from the city at that time. And of course, now gradually the houses have moved to that place. And I need to change the source of my water to well, sink. I also have a well, but it's not deep enough. However, I channel my water from the river into my pond, and as it is coming out, it's also going out at the lower end. We call that one flow-through system. Constantly water is coming in, and it's also going out. So that's the best way. And of course, we should know that all the negative chemical and environmental factor, can affect your source of water, the quality of your water. All of this determine the quality of your water, like I mentioned to you. Okay, now we're going to look at the physical characteristics of water. We just look at water generally and their source, but let's look at the physical. We also look at the chemical, characteristics, but physical first. Now, water, in terms of the taste and odor, are themselves definitive in their parameter. Tasteless, and it should be odorless. Okay, but when we look at the temperature, you see, we told you before that water will always take, the fish will take the temperature of the water bodies they find themselves. And so temperature of the water can affect their activity, can affect their behavior, it can affect their feeding regime, can affect their growth processes. More importantly, it will affect their reproduction. And that's why we must take the temperature very seriously. It's part of the discussion, I want to pay attention to, but you can offer your own mind, as to that discussion we posted on our platform. Okay, so temperature, but we focus it on a particular, another parameter. So it plays a major role in thermal stratification. That means, the different, if you look at the water body from the top to the bottom, you will find that the temperature vary from one region to the other. So what the fishes function in different, there are different fishes that can function in different, level of water. We call it thermal stratification. We won't go into deeper, just know that water, has different stratification based on the heat that it absorbs in its body. And also the dissolved oxygen, which is DO, represented by DO, level decrease in the bottom layer since photosynthesis and contact with the air is reduced. Okay, that is stratification I'm talking about. The dissolved oxygen. Photosynthesis happens, when the sun meets with the plant materials in the water. Okay, and therefore oxygen is released and we have dissolved oxygen level. So we are saying that the bottom of the pond, we have lesser dissolved oxygen levels. So we should know that, because this particular factor, we'll talk about it later, is very critical for the survival of your fish in that water body. And so again, we're still considering the physical characteristics. We look at the temperature first. But this if you look at this pond, you will see green materials there, suspended solid, they are all there. These are very large particles standing in the water. They stand in water over a period of time. And of course, they have the physical property, and they have negative electrical charges that are usually associated with them. This affects your fish growth, and it must be managed. We'll tell you more about it when we manage very well, but it's a physical characteristic of water that you also find. Another characteristic of water, of physical characteristics, is a plankton organism in water. You can see them. They are both plants, they are also animal. All of these are in the water body. They are very good food for fry and fingerling and even juvenile. They are very, very good food for them, especially the zooplankton. So when they are the microscopic plant, we call them phytoplants. When they are animal, we call it zooplankton. Of course, the green algae also is phytoplankton. Okay, so they all exist in the water body, and it's a physical characteristic. The next one, as you can see, this brown, on the surface of the water, this brown concentration, this brown clay also, but we know that the concentration of the concentration, we call it turbidity, is often greater than 2,000 parts per million, always greater than that. Okay, now if you look at this brown thing here, always it resists, it does not allow for light penetration. It limits photosynthesis. That also means that the dissolved oxygen level will be very low, and it's not good enough for fish production. It limits dissolved oxygen. Anything that limits the dissolved oxygen, we also limit the growth rates and productivity of that water body, at all. So even the phytoplankton, zooplankton, they must not be too many in your water body. They will also reduce because they also, compete with the fish for the dissolved oxygen as well. But the fish also take advantage of them, as we have shared with you. Now, the remedy here of this turbidity, because of the negative impact, it has on fish, the remedy that is often suggested and used is a Gamson application, okay, or 7 to 10 square daily of hay on the surface. Once you just put it on the surface, it will clear the clay turbidity. The turbid nature of the water will be cleared, and there will be active photosynthesis that will enhance your fish production. Okay, now we come to the chemical characteristics of water. Okay, the first we're going to look at is the photosynthesis. Okay, I'm sure I told you that there are plants, small zooplankton, but there are also other bigger plants that we found at the edges or at the bottom of the river, as the case may be. Okay, now this particular plant release oxygen into the water through the process of photosynthesis, okay? But it will now take the carbon dioxide, and it must be regulated. Okay, it must be regulated so that we will not have deficiency in in all of these gaseous in the water body. So all of this, in this water body, for example, we have dissolved oxygen, carbon dioxide, the pH cycle, and the nitrogen water waste. All of these take place here. So we must ensure that it is regulated. All these water quality parameter, dissolved oxygen, carbon dioxide, the pH cycle, nitrogen waste production, and their impacts is regulated through the process of photosynthesis. Now, the second chemical characteristics is the dissolved gas. Soda water, which has large quantity of dissolved oxygen, we see it in that water body. These are the carbon dioxide plus water forming a carbonic acid. You see, this gas, there is a gaseous exchange in and out, depending on this activity of the photosynthesis, the activity of the zooplankton and the fishes in the ocean, in the water body. There is gaseous exchange. It emits carbon dioxide, taking oxygen, emit it. All of these things take place. You can see bubble-mediated gas exchange. They all happen. And the concentrations are measured in parts per million. Just like we have a horizontal, mix, we also have a vertical mix as well. Thirdly, we have been talking about this from time, the dissolved oxygen. We talk about the photosynthesis, dissolved oxygen, dissolved gases of different form. All of this gas also takes place in the water body. They are all chemical characteristics. Now, we also have dissolved oxygen and the water temperature. Okay, like I told you before, there is stratification. There's stratification, that is caused by temperature. We have the thermocline, which is the middle. We have the epimon, which is the temperature is high here, and we have hypolimon, low dissolved oxygen, low temperature. We have high temperature, high dissolved oxygen because of the interaction with sun. Remember, we told you that the deeper you have the water body, the lesser, they have access to light, and in that wise, the temperature will be low, the dissolved oxygen will be very low, and it's not very healthy for the fish. Now, if you look at this now, we told you that we're showing you that there are different range of dissolved oxygen that the fish can tolerate, range of tolerance for dissolved oxygen. Now, this is measured part per million of dissolved oxygen. Now, if we have too low for fish, that means if it's less than 3.6 part per million, no, 3.0, sorry, part per million, then range of tolerance stress, you see, when fish is at stress, okay, for within 12 to 24 hours, they will be stressed if the dissolved oxygen level is between 3.0 to 5.0. And by the time we get to 6, you observe, can you see that there are no fishes in 0 to 3 to 4? But by the time you start having, 5.0 part per million, this supports, production, spawning. By the time we move to 7 parts per million, it supports growth and activity. And by the time we are getting to 10 parts per million, it supports abundance of fish production. So you have to pay attention to dissolved oxygen. That's why in pond, when it's getting, when the weather is getting lower, the sun, for example, between 5, what I do in my farm is that between 5 and 6, or probably 7, you go and disturb your water. Just stir the water in the pond. Because you did that, it will create a bubble. There will be a mixture of atmospheric oxygen and the water itself. And that's why in concrete tank, you can ensure that water is coming in and out continuously so that you can have a healthy state at which the dissolved oxygen level is very is high enough for abundant fish production. The higher the part per million dissolved oxygen, the better for your fish production. Now, we're still looking at the chemical characteristics. And in this, we're looking at the ammonia, the nitrogen here. Now you find here that this is the fish. It eats its own food. It emits carbon dioxide here, even though it takes oxygen. And this oxygen, this carbon dioxide reacts with the ammonia, and through the natural butter, and it becomes nitrates. And from nitrates, again, it becomes, by the help of the natural butter bacteria, become nitrites. And this nitrite is very poisonous to the fish and must be removed. It's often removed by plant and water exchange. That's why it's very important to keep adding water to the existing water in aquaculture. So we have two forms of ammonia that occur in aquaculture system: the ionized and the unionized. The unionized form of ammonia is extremely toxic. This particular one, the nitrites, is toxic. Okay, but however, the unionized is, which is the ammonia, which is the ammonium is not. The ammonia is, the ammonium is not. So you must know the difference. And the only way to combat it is to ensure that, the nitrites and the ammonia are continually removed from the water body. Of course, you can dilute the water body, dilute it, or, find a way of allowing plants to be in that water. The plant will take it up, out of, the water body. The next characteristics we're looking at is the carbon dioxide. The carbon dioxide itself. And we said it's the fish, take in oxygen and emit carbon dioxide, which is required by the plants also. Also, if you look at the carbon dioxide, the clay and the limestone at the bottom of the pond also emit, release carbon dioxide and also take in all the fish's hair as well, all the organism here, the zooplankton, more importantly, does that function, of taking in, the oxygen. So in intensive pond, okay, intensive pond, from 0 part per million to, in the afternoon to 5 to 15 part per million at daybreak. These are the best, carbon dioxide, range that are very important for intensive pond, and also less than 5, part per million of free carbon dioxide is also good enough. Okay. However, when we look at the recirculating system, recirculating system, it should exceed 20 part per million. It should exceed that, because the activity there is rigorous, and of course, water is constantly being recirculated, for purification and brought back to the to the chamber. Okay, and how do we remove this free carbon dioxide? By adding carbonate, like we said, same thing applied to this, by adding spring water from limestone, bearing rock. The last, okay, there are 2 of them here. This one is pH. It's also a chemical characteristics. Now, if you look at the pH here, it ranges from 0 to 14, 7 being, the ideal pH. However, pH, if pH gets too high in the afternoon, it may be necessary to improve the buffer capacity of the pond and prevent excessive growth of phytoplankton. Okay. Now, if you get to this level, death of the fish, it can create death because the zooplankton will cover the surface of the water and there will not be photosynthesis. The dissolved oxygen level will now be very low. Okay. And if it's too low as well, 0 to 5, the pH often has to correct, the pH, total alkalinity is liming. So if we lime this place, we bring it back to at least between 7 and 8 pH, which is the best pH for freshwater fish. Okay. And of course, the same applies to the marine water pH. But like you can see here, this red zone, we call it the death zone. Then by the time you are moving from 5 to 7, you are being warned. So these chemical characteristics can help you manage your pond very well, because knowing these things and knowing what operates there, and the interrelationship between all of this thing happen in the water body. So it's not, they are not happening in isolation. So pH will tell you that, the oxygen level is very low. My fish will suffer if I allow it to continue. I should add lime, I should add water to it, to ensure that I have optimal production of fish. Finally, we're looking at the hardness of water. And this also plays a major role in fish production. When we have less than 1, it is soft. Between 1 and 3.5, it is slightly hard. Between 3.5 and 7, it is moderately hard. And 7 to 10, it is hard. And over 10, it is very hard, depending on which measurement you are using. If you are using grain or part per million. Okay, so you need to know the water hardness that is best for your fish. And of course, is a moderately hard water scale. So knowing all of these things will help you manage your aquaculture, manage your fish that is in the water. Okay, so now you need to also know, you need to know, okay. The next thing we are looking at is the eutrophication. The eutrophication is the aging process of the pond. Now, if you look at the sun shining on the water, there is photosynthesis, nitrogen is being introduced, phosphorus is being introduced, there is algae bloom because of all of this interaction of the sun and the phytoplankton, the plant, the sea grasses, oxygen is coming in, the decay, there's phytoplankton growth. All of these things, can cause a standing pond to begin to decay. So and when that begin to happen, there is loss of food, loss of habitat, and oxygen production because of the multitude of activity that is happening in that pond. So it can also no longer support aquatic life. So it should be guarded against. Eutrophication should be guarded against. And the rate and the level of eutrophication attained by a particular water body is based on the physical and chemical characteristics. All the chemical and the physical characteristics that we have shared with you, we have brought to your attention, if you don't balance it up and make sure it's there in the right states, it can cause eutrophication. It can cause the pond to become what we could become dead. And we have, different trophic level, in an aquatic ecosystem. We have oligotrophic, we have the mesotrophic, eutrophic, and hyper-eutrophic. Now, when we have oligotrophic, that water body is very healthy. We have low organic matter. We tend to be deep and clear. Oxygen is very rich because it's exposed to the sun, and it supports cold water fish such that the trophy phosphorus is limiting. Okay, but the mesotrophic, more organic matter, oxygen level is lower than what we have, in the oligotrophic. At the bottom of this pond, you see the death process already started happening, here already, because there are more activity, there's more organic matter, more than what we have in the oligotrophic. So what the eutrophic is becoming unhealthy, high level of organic matter. Can you see it on this water body? Yes, high level of organic matter, abundant of plants that is struggling, that is fighting for the oxygen and producing other, clay, brown material that we show you in the physical, in the physical parameter of water, characteristic of water. So the abundance of plant, poor clarity, is no longer clear, stratified with oxygen, poor bottom. Oxygen here is very poor. And of course, the last one here, which is the hyper-eutrophic, is severely degraded, dead zone, in an area where oxygen level fall below 2 parts per million. Now, how do we manage the phytoplankton? It's very simple. Reduce the nutrient input in the form of feed. Don't just go and pour your feed unregulated. You have to reduce the nutrient level so that you can have a clear water surface. Then when you add phosphorus, granulated phosphorus, it's like this man you see, in this pond that has become brown, full of phytoplankton. When you pour phosphorus or copper sulfate into it, the bloom, will be taken care of. Use the copper sulfates. Tinning the phytoplankton bloom, we can tin it. Sometimes we can even use canoe and net to drag, the phytoplankton out. If you go to, the lagoon, for example, you will see many of them covering the water surface. Sometimes you can tin them, you can harvest them out of the water body. Also, we also use of dye to shade out dense phytoplankton. These are ways we can manage the phytoplankton so we can attain maximum fish production. Now, there are many practices, beneficial practices, which improve water quality. We'll be showing you, 3 of them. Yes, 3 of them. Watershed management, managing of agricultural input, and water treatment for use. And in shed, if you look at the picture here, you divide this surface so that the water does not easily take away the nutrients away completely. So it protects both the surface and the underground water. The aquifer is protected. This is the water mouth. This is the divider, that happen here. So what we do is surface of the water supply, the dugout, the river, precisely what we do by watershed. It does not allow, the water to just move freely as to take all the nutrients away or as to cause a situation where, the water stay and become waterlogged. So water can easily move away from, water can easily move away from the big water body. So that's one way we can manage water such that we can have high water quality. Also, we have to be careful the way we apply our chemical, around our water body. So we must properly handle our fertilizer, manures, and pesticides so that it will not flow to pollute the water body, into which feed, we find our fish. If you don't handle it very well, and any of these things find their way to the water body, you will just find that all the fishes will just die, overnight. And we must be able to also handle our storage, the mixing and the handling of all of this pesticide, fertilizer, manure. We must handle it proportionately and wisely. And of course, water treatment for use. Okay, we must treat our water and do it wisely. The purpose is that we aim at maintaining and improve water quality. Now, what you see here is the recirculatory system. All the water, that come into this pond is being recycled, is being repurified and brought back for use. This is intensive fish culture that you can see here. So these are the practices that the best practices and beneficial for improving water quality. The second activity I would like to pay attention to and also attempt is how will you manage a case of phytoplankton bloom in your own farm? How will you do that? Oh, since I don't have any student here, in case you are watching this afterwards, you can send me an email and do your own research, beyond what I've said, and come up with your answer and post it to me. So hopefully we are going to meet again. As I told you, make sure that you go to the platform, take advantage of everything we have taught, and answer all those questions. Attempt the discussion class and post your finding. Okay, I think I'm not through yet. Yes. Let me talk about management of water sources. Yes. Okay. Now, best management practices to sustain the best possible water quality at the source. What are the best management practices? Proper siting and design of the river and dugout. Remember, I told you how I site my pond beside the river, and I allow it to come in and also go out. Number two, selective and limited use of algaecide in farm pond. We just told you about that you be careful with your chemical, your pesticide, your fertilizer. Okay, algaecide, be very careful. Select the best one, proven ones that are that will not cause toxic, that will not be toxic to your fish. Control of surface water inflow into the reservoir, very important. Okay, I told you I have to control it by putting different pipe, the amount of water that come in, I know, so that it will not be overflooded and it will take your fish away. Use of biological, chemical, physical technique, such as aeration. I told you about that. Aeration, because the dissolved oxygen level, at a point will begin to drop. Okay, and you cannot afford to allow it to be so. So you apply aeration, either physical aeration, or you connect a pipe to it where you blow water into the water body. Coagulation and reservoir clothing is very important so that you can maintain the right temperature. I remember when I took my fish to Jos, very cold environment, I had to cover the reservoir, cover the pond, and create an artificial heat temperature for my fish to survive. The best management practice for underground water. We look at the surface water, it's underground. Diverting surface water runoff away from the well pits, very important. Protecting sensitive aquifer, the bottom of the water body. You must protect them. Preventing maintenance, preventive maintenance, such as stock chlorination of well when necessary. That means that you want to be able to increase the pH of that water body. So these are the way of managing your water sources, whether they are surface water or the underground. You manage them by all of these techniques so that you can attain maximum fish production. You manage your water body well for effective and sustainable fish production. So I wish you the best, and I hope that we'll meet next week. I will get in touch with you through your various email and our WhatsApp group that we have just set up. So please tell your colleagues. The class is 5 o'clock to 6. I hope to see you next week by the grace of God.